Our success as a species has much to do with our ability to adapt to changing conditions and available resources. Climate changes, natural disasters, and discovery of new resources have all greatly affected societies in the past, and will continue to do so into the future. We will start today with a look at what affects our planet's climate. Variations in the tilt of Earth's axis, precession, and orbital eccentricity all contribute to changes in the amount of light striking the Earth's surface at different latitudes. This in turn affects climate. The tilt of our axis varies between 21.1 and 24.5 degrees. Currently the tilt is 23.5 degrees. To go from its maximum to its minimum and then back again takes 40,000 years. Precession is the wobble of Earth on its axis. This cycle lasts 26,000 years. And the shape of our planet's orbit varies on a 100,000-year cycle. A Serbian astrophysicist, Milankovic, first proposed that these cycles are in part responsible for the cycle of ice ages and warm intervals that have occurred on Earth. Our last ice age ended over 10,000 years ago. Temperature lows are observed in past climate data that occur on a roughly 100,000-year cycle. Was Milankovic on the right track? Lows occurred at around 350,000, 250,000 and 150,000 years ago. It wasn't quite as cold at 50,000 years ago. How do we know what the climate was like in the distant past? Proxy data. Proxy data includes tree rings, sediment varves in lakes, pollen found in sediment, coral growth rings, coiling of shells and foraminifera. Read more about proxy data via a Google Classroom assignment. Paleoclimatology, how can we infer past climates? In Neogloboquadrina pachyderma, the shell coils to the left when the protist grows in cooler water. It coils its shell to the right when it grows in warmer water. This makes it an excellent source of proxy data for past climate. Assign activity, climate analysis using planktonic foraminifera. Compare your graph of the temperature for the past 160,000 years to the graph on a previous slide. The Maunder minimum was a period of time when the normal solar cycle was disrupted. There was an extended period with little to no sunspots. This caused a cooling of our planet. The graphic shows that when sunspot numbers are low, so, too, is solar irradiance. Solar irradiance refers to the total amount of energy of all wavelengths reaching the Earth. If less energy is arriving to Earth from the Sun, the planet cools down. During the Maunder minimum, Europe experienced a prolonged Little Ice Age. Crops failed, people starved. Prior to the Maunder minimum and the Little Ice Age, there was a medieval warm period. Life was good. Populations grew, and there was pressure to explore and seek new lands. The Vikings colonized Greenland during the medieval warm period. Viking explorers did not stop once they reached Greenland. There is evidence that they also reached North America, especially in Newfoundland. Vikings explored the North Atlantic extensively in the early 11th century, 1000 AD. They settled on Greenland and may also have had settlements in North America almost 500 years before it was discovered by Columbus. The Vikings arrived in Greenland late in the medieval warm period. Once their colonies were established, average temperatures began to decline as we entered the Maunder minimum, and the Little Ice Age began. After 500 years, the last Vikings left Greenland. The abandonment of Greenland does show that climate does affect human migration patterns. Go to Google Classroom and complete the Living During the Little Ice Age activity.